This video is a tutorial on how to do video analysis with LoggerPro. In order to do video analysis, you have to shoot a video of some motion that you want to analyze. We did this in class and dropped a ball from the second story. So I'm going to pull up a student video of dropping a ball. Before I do that, I need to make a page on which to put the video. I like to keep my videos on a page of their own, separate from the data. So I'm going to go to the Page menu, choose Add Page, give the page a title. I call it Video, and then choose OK. So this is the page on which I'm going to place video. In order to do that, I'll go to the Insert menu and choose Movie. LoggerPro calls videos movies. So insert movie, and we need to navigate to where the video is saved. Okay, so it's here, it's called ball drop. The next thing I do is move it and resize it to take up as much space as possible so that it makes the marking of the video much easier. So I'm using the handles around the video to resize it. Now I'm just going to play it to get a sense of what the motion is. Click on the play button in the lower left corner.
Go.
Okay, so I'm going to click on the third button to rewind it all the way to the beginning, and then single step through until I get to where the motion begins, which is kind of hard to tell on this particular video. So I'm actually going to start right around frame 34. I know that the ball has already left the hand at that point. We tried this earlier in class and found that any frames before frame 34, we weren't really sure if it was still touching the hand or not. So that's going to be the beginning point. And in order to do video analysis, you're going to have to mark points on the video where the ball is at particular times during its fall. Before I do that, I'm going to change some of the options for the movie. So I go to the Options menu and choose Movie Options. And here I can change various things like the speed and some other stuff. One of the things, I can override the frame rate. This movie was shot in super slow-mo with an Apple iPhone 6, and they shoot slow motion at 240 frames per second. So I'm going to tick this box and change the 30 to a 240. And I want, when I mark points on the video, it's going to make data points on a graph for me. I want the very first point to correspond to time 0. So I'm going to tick this checkbox. VA means video analysis, so the first video analysis point will be time 0. I also know that if I try and use every single frame, very little movement takes place from one frame to the next frame. And so I know that I'm going to need to advance more than one frame after each point that I mark. Now, we've already done this as a class, and we did 5 frames. And after analyzing the data, we determined we could probably get by with 7 frames instead of 5. So I'm going to advance 7 frames between points. Okay, so how do you mark the video? Down in the lower right corner is a button with 3 red dots on it. When you click that, it enables the video analysis buttons along the right edge. The second button down is the one we use for adding points. The third button down is to set an origin, and the button below that is to set the scale. We're going to use all 3 of those buttons. So first I'm going to mark points. So when you choose the Add Point button and then bring the mouse over the video, it changes to a crosshairs cursor. And I'm going to place the ball in the center of the crosshairs and click. And it puts a blue dot where the ball was and then advances the frame of the movie 7 frames. So now I'm going to do that with the next place. I'm going to try and be careful about where I'm putting this, where I'm making these marks, so that my data is as good as it can be. Now, motion gets blurred when you shoot it with a video camera, even one at 240 frames per second. So it can make it a bit challenging on where exactly the center of the ball is located. So I'm trying my best here. You may notice that the dots are kind of goofy. They're not uniform left to right, but vertically they are looking pretty good. If an object is falling and picking up speed as it goes, the distance from one dot to the next dot should be increasing because it's covering more distance per unit time. And so far it looks pretty good. You may notice as I'm doing this that on the right hand side of the screen is a graph that is filling in with data points as I go. It's filling in with 2 sets of data points, the blue and the red. The blue is marking the vertical position and the red is marking the horizontal position. Horizontally there should be very little change. And in fact, when we look at our data after we mark these, we're going to get rid of the horizontal because it doesn't matter. And I'm not going to mark all the motion. I'm only going to mark that which is against this white background because it's easy to see. And one more. Maybe a couple more. Okay, that's all. Okay, so I've marked the points, and I now need to use this Set Origin button. I want to set the origin with my first point. So I'm going to go ahead and click the button, but before I set the origin, I'm going to back this up so I can clearly see, I can pretty much clearly see the first point. What I normally do is I back it all the way up to where there's only that one point on the screen. So I'm just going to drag this slider back. Now I'm going to use the buttons for one frame at a time until the point goes away. And then one more forward to bring it back up again. There it is. So I'm going to put the crosshairs right over that point and then click, and it puts the coordinate axes on there for me. The next thing I need to do is tell LoggerPro what the scale of this is. How long is 1 meter? And then we have 2 meter sticks in the picture. One down here and one up here. And it looks like the one up here is closer to the ball as it falls than the one down here is. So that matters. You need your measuring stick to be as close as possible to the motion to get accurate numbers. So I'm going to click the Set Scale button, and then what I want to do is I want to click and drag over some object in the picture, the length of which I know. And so this meter stick is 1 meter long, actually not going to put it in the crosshairs because it's hard for me to see, but I can see that left part of the crosshairs is even with the end, and I'll run it up to where the left is even with the other end, which is right there. So that's 1 meter. The dialog asks me, okay, how long is that? So that's 1 meter. I'm going to just accept that. Okay, the scales on the graph changed according to the scale that we just set. Now I'm finished marking the video. I want to go back to the page that has the data table on it, which is the first page. You can navigate pages by using this drop down here, or by using this previous page button or this next page button. Since I only have 2 pages, this is the quicker way. Alright, so I have a graph in a data table. I'm going to resize things so I can see the graph a little better. I'm going to select, so I can see the data table better. I'm going to select the graph by clicking on it, and then use the little handles to change its size a bit. Then I'm going to click on the data table and grab its handle so I can change its size, and then scroll. So there's my data. As I said earlier, we don't need to know how far it goes in the x direction because this is a vertical motion thing. So I want to delete the x column. I'm just going to simply click on the heading and then hit the delete key on my keyboard. Now I'm using a Mac. It's called delete. On a PC, I don't know if you use delete or backspace, but you might try both. It got rid of the x position and it got rid of the x velocity column. So now all I have left is time, the y position, and the y velocity. So resizing the table, I'm going to resize the graph. Okay. So far so good. Now we need to get the data to show up on the graph. To do that, as you move the mouse cursor over the graph, the shape of it changes depending on where it is on the graph. For example, over vertical axis, it changes to this weird rubber bandy looking thing with arrows on the ends. Or if you move it farther to the left, it changes to a Y. On a Mac it says Y dot dot dot. On a Windows PC it just says Y. If you click there, then it gives you a menu from which you can choose what you want to put on the Y-axis. I'm choosing more off the menu. I'm going to tick the checkbox for Y, that's the Y position. And while I'm here, I can add a label, so I'm going to do that as well. I'm going to call this vertical position. And in parentheses after that, I'll put the units, which in this case are meters. Click OK, and now I've got vertical position on the left, and the LoggerPro took a guess that time might be what you wanted to put on the x-axis, which is true. Now this looks great, except it's super tiny. There's a button up here at the top that has a letter A with a graph around it. That's your auto scale button. You click on that, it'll scale it up to where it's really nice. So this graph is in the shape that we might expect for an object that is picking up speed as it goes. As time increases to the right, the time axis is up here at the top actually, the distance that the object covers vertically gets bigger and bigger and bigger. So that's why we have this curved graph. We would expect that shape to be parabolic. This particular graph doesn't really show me that much. What I want to look at instead, in order to figure out what the acceleration is, which was the goal of this assignment when we started it, is to, instead of graphing vertical position, I can graph the vertical velocity. So I'm going to more. Instead of position, I'm going to say velocity in the title. It's meters per second. And I will untick Y and tick Y velocity. and click OK. Now we've got a graph that looks really weird. I'm going to auto scale this, see if that makes it look any better. Okay. So it's bigger and it's easier to see. Now, you may recall that the slope of a velocity graph is acceleration. And so what we want to do is find the slope of this. And there's a button up here called linear fit. So we can do a best fit line that fits this data and then find its slope. So I'm just going to click that. And it adds a best fit line and a little statistics box here telling us about the fit. And it tells us that the slope is negative 6 point something, which is unfortunate because the acceleration due to gravity isn't negative 6 something. It should be closer to negative 10. So what's going on with our data? Why is it messed up like this? Not really sure. I think at the beginning there might be some funny business about how the ball was released. So I want to exclude some of that data. And I hovered over that square bracket, and I'm going to just bring it over to where it looks like the data might be starting to look like it's supposed to. Perhaps there. The tail end of the data also does something weird. It starts kicking out at the end. So something must be going on there. When I asked students about what kind of ball was used, they thought it might be like a wiffle ball or something. If it's a ball that's extremely light like that, then air resistance is going to play a big role in its motion. So I'm going to exclude some of these points towards the end of the motion that I marked, just in case the air resistance was a really big issue. Okay. And so with that much data marked, we've got a slope of negative 7.7, almost negative 8. So that's closer to negative 10 than what we started with. I'm going to exclude one more point up here and exclude a bunch more points down here and just see what happens. If I go to there, that's negative 11, negative 10, negative 9.5. And what I'm doing right now really is not good experimental technique or analysis technique. I'm just curious to know what the slope is at those various, when I include various amounts of the data. But just judging on the overall way the data is laid out, it looks to me like probably this much is fairly decent, which is approximately what we had a moment ago, which gives us a slope of negative 7.7-ish. Okay, basically that's it as far as doing video analysis for this particular problem to find the acceleration. One thing that I would like to show you is instead of just one graph, you might want to have multiple graphs at some point. So I'm going to make that one smaller and go to the Insert menu and choose Insert Graph. Puts another graph up. Happens to be the same thing I just did. I'm just going to resize it, reposition it, and make this one, instead of y velocity, I'll make this one the vertical position that I started with initially. And so that's how to get an additional graph in your file. on this, since it's curved data, I can do a curve fit, which is this one, and fit a curve to it. For this particular data, it's probably closer to quadratic than anything else in here. And so that's fitting a quadratic to that data. One thing I failed to mention over on this other graph is that the correlation tells you how good the best fit line actually fits the data. And you're looking for a correlation extremely close to 1. So 0.99 is very close to 1. You can ignore the negative sign. If it's 0.98 something, that is not close to 1. That is not close enough to consider it a good fit. It needs to be 0.99 or greater. Okay, so that's the end of this tutorial. Hopefully that will help you when you do this for yourself. You can refer back to this and replay various parts of it. Thanks for watching.